Hi guys, this is Prashun again. Okay, today we will go through some of the properties of logarithm. In my earlier video, we have discussed what is a logarithm and how logarithm was introduced into the mathematics world. Logarithm can be used, is being used in many physics problems or your engineering studies or in the field of economics and many places. So it is very much important to know the properties of logarithm, so that and this is useful for our joint entrance study, because either we have to deduce those formula, as well as this formula will be used to solve multiple problems. Okay, so let's move properties of logarithm. uh, just for our sake, like if x equal to a to the power n, then log to the base a of x equal to n. So this is the fundamental theorem through which all the formulas will be derived. Okay, so let's go ahead. Here if I write a I can write as a to the power 1. So similarly, if I see by comparing with the above expressions, so log to the base a equal to 1. Okay, so first law of logarithm is called multiplication law of logarithm also. So let's see what is that. Let's say x equal to a to the power n and y equal to a to the power m. So equivalent logarithm forms are log for the first term, log, then a is coming as base, log to the base a, x equal to n. And similarly for the second term, the base is a, so log to the base a, y equal to m. The power becomes in the right hand side, and base is the base of logarithm. So using the first rule of indices, we know if I multiply x into y, at that time a to the power n into a to the power m. That means a to the power n plus m. Now the logarithm form of the statement equal to xy equal to a to the power n plus m is, if I think xy as x in the first line, so log to the base a, because base is a, xy equal to n plus m. But n equal to, we have already deduced in equation 1, n equal to log x to the base a and m equal to log y to the base a. So putting these rules together, log of a, log to the base a xy equal to n plus m. N means log x to the base a and m means log of y to the base a. So if we want to multiply two numbers together, find the logarithms of the results, we can do. This is by adding together the logarithms of two numbers, and this is the first law. So multiplication of two numbers, if we take multiplication of two numbers of logarithm, then we individually can sum up the logarithm, and that will come as a result of logarithm with the logarithm notation. Next one is second law of logarithm. The second law of logarithm is also called the division rule. Here in the first law we have done the product operations. In the second law we will do the quotient operations, and let's see what is this. Very easy. Suppose x equal to a to the power n. So I can write log x to the base a equal to n. Suppose we raise both sides of x equal to a to the power m n to the power m. So x to the power n m equal to a to the power n then whole to the power m, because x equal to a to the power m. So using the rules of indices, we can write this as x to the power m equal to a to the power nm, because a to the power n into m. Thinking of the quantity x to the power m as a single term, the logarithm form is log to the base a x to the power m equal to nm. This is coming from this expression. or nm means m and n equal to log x to the base a. So m log x, this is the second law. It states that when finding the logarithm of a power of a number, this can be evaluated by multiplying the logarithm of the number by that power. So basically here we are putting like log log to the base a, then x to the power m, then it becomes m. This m is coming as the coefficient, so m log a, x to the base a. This m, whatever is there in the power side, that is becoming in the multiplication side of log x to the base a. So this is the formula. One thing I have mentioned wrong, that I was telling that second law of logarithm is called the quotient rule. Actually that is the third law of logarithm. The second law of logarithm is multiplication rule. Like if something is having a power, that power is coming as the coefficient in the left hand side of the logarithm expression. So this is the second law of logarithm. The third law of logarithm, which I already mentioned, that is the basically the quotient. Like x equal to a to the power n, I know, and y equal to a to the power m. These two things I am taking as a consideration. Now for the first thing, x equal to a to the power n, I know that this can be represented as log a is the base, so base a, then x equal to n, and log for the second expression, I know that log y to the base a equal to m. Now considering x divided by y. So if I divide x by y, it means a to the power n divided by a to the power m. Now as per the indices formula, this means a to the power n minus m. So now in the logarithm form, if I go log of a x by y means log of a x by y equal to log of x to the power base a minus log of y to the base y a. So this is called the third rule and the third law of logarithm. You are I think you people are not able to understand like why this log x to the base a and log y to the base a is coming. You know that here I am writing x by y equal to a to the power n minus m. Now from here I can say that log x to the base a means n, right? Log x to the base a means n, and log y to the base a means m, so n minus m, and I am taking the log of the base x by y. So this is the third law. What is the logarithm of 1? Any number raised to the power of 0, that is a to the power 0 equal to 1, I can write that anything to the power 0 equal to 1. That was the proof which we have done in the class of 7 or 8. So if a to the power 0 equal to 1, if I write in the form of logarithm, that it becomes log a is the base, so to the base a, then 1 equal to 0. So that is another formula. What is the logarithm of 1? Because this logarithm of 1 we have to use in many places in the problems and solutions. Another important proof, that is log a to the base b equal to 1 by log b to the base a. That is the bases interchange, like it is the opposite base when it is 1 divided by. So let's try to find out the log 25 to the base 5. What is the result? 5 square equal to 25, so it means that log 25 to the base 5 equal to 2. That's fine. Again, if I try to find out another logarithm, that is log 5 to the base 25 equal to 25 to the power half means 5, because root over 25 equal to 5. So root over 25 I can write in the form of 25 to the power half equal to 5. So if I take this as a logarithm, log of base 25 then 5 equal to half. So I can see that first expression is my log 25 5 equal to the base 5 equal to 2, and the second expression log 25 to the base 25 equal to half. So they are the opposite of each other, they are the reciprocal of each other. So basically we can see by interchanging the base and the number, log 5 to the base 25 equal to 1 by log 25 to the base 5. Next we will consider two bases. Like in the logarithm study, there we will encounter two types of bases. One is the base 10. Whenever log is coming with base 10, that is called logarithm, and whenever log is coming with the base e. Why e is coming? Because e is called the exponential constant and has a value approximately equal to 2.718. This is a number like in the sense that it has an infinite decimal expression. This is called Neperian or natural logarithm, because in your physics problems or thermodynamics problem or anywhere, when we have to calculate, we have to take the base of e. So log e called the natural logarithm. Log to the base e is called the natural logarithm, and log to the base 10 is another common logarithm. So log 10 is called log 10 equal to 1, and ln e equal times we write the natural logarithm as ln. So thanks for going through all the properties of logarithm, and in the next video we will go through the different types of base and how to change the base of logarithm, and then we will go to the problems and solution of different kinds of which has come in the joint entrance examination. Hope the properties are okay now. So thanks for watching my video. If you like, please like and subscribe to my channel so that it can be reached to wider audience. Thank you.